So here, if the signal xn is periodic with a time period n, then we can write xn is equal to x of n plus minus n. So if we assume that the signal xn is equal to e to the power j omega n, then x n plus n, capital N, can be written as e to the power j omega into, in place of n we have replaced with n plus capital N. So if we expand this one, then we can write e to the power j omega small n into e to the power j omega capital N. So e to the power j omega small n, this portion represents the original signal xn. So we need xn plus capital N is equal to xn. So this portion is extra here. So to be periodic, this must be equal to 1. So if we consider e to the power j omega capital N is equal to 1, where n is the time period of the signal, periodic signal, so we can write like, by expanding this, e to the power j theta, where theta is equal to omega n cos theta plus j sin theta. So cos omega n plus j sin omega n is equal to, for comparing here, we write this 1 plus j0, where j0 is equal to 0, so it is 1 only, so 1 plus j0. So we can compare this, cos omega n is equal to 1, and this dc part we can compare, cos omega n is equal to 1 and sin omega n equal to 0. So if we take the first part, then cos omega n equal to 1 equal to cos 2 pi k. So we know that cos 0 equal to 1, cos 360 degree equal to 1. So if we take k is equal to 0, 1, then we can get cos 0, cos 360, all these values. So in a general solution, you can write cos 2 pi k here for 1. So if we solve this, then we get omega n is equal to 2 pi k. So from here we derive n is equal to 2 pi by omega into k. So since capital N is an integer, because it should be integer because it is a time period, so on number of samples after which the discrete time signal is repeating, so it should be integer. So since pi is not an integer, so omega must be in the form of pi, multiple of pi, so that pi can be cancelled out and we get an integer value for n. So omega must be in multiple of pi. So for this signal, if we find time period capital N is equal to 2 pi by omega is 6 here into k. So if we take the least value of k is equal to 6, then you can cancel out this 2. Okay, this 2, but we'll get n is equal to 2 pi. So since pi is there, so it is a periodic signal, a periodic. So mind that when pi is in time period for continuous time, it is okay, but for discrete time signal, pi cannot be there in the time period below, because in discrete time signal, if we see the plot like this, what happens, as samples like this repeats. So this 3 number of samples n is equal to 3 is the time period here, so it is repeating, this pattern is repeating. So this type of number of samples becomes the time period in discrete time signal, so here pi cannot be there. Okay, for this signal n is equal to 2 pi by omega here 6 pi into k. So pi cancel 1 by 3 into k, means for k is equal to 3, it is equal to 1. Put k equal to 3, then it is equal to 1. So time period n is equal to 1 only. So here we have 3 time period and 1 is equal to 2 pi by 6 pi by 5 is equal to pi cancel, so So it is 5 by 3 into k. So is equal to 5 only. 5k by 3. So 5 for k is equal to 3. So for n2, this is not 6, it is 6 by n by 7. So n2 is equal to 2 pi by 6 pi by 7. So it is equal to 7 by 3 into k is equal to 7. So n3 is equal to 2 pi by 5 pi by 9 is equal to 18 by 5k is equal to 18. So n is equal to LCM of these three. N1 means 5 only, 7, 18. So it will be multiplication of this 3. 35 into 18. So 50, 40, 90, 30, 24, 54, 0, 3, 6, 30. So this is the answer. N is equal to 630. For this first signal, we can write this like e to the power minus j into 0. So this is 1 whole to the power n. So whole to the power n. So here minus means a minus will be there. So n. Or you can write minus e to the power minus j 0 n, or equal to minus of cos theta means cos 0 minus j sin 0. So it is equal to minus 1 plus 0 or equal to minus 1, or cos pi n. So capital N is equal to cos 180 degrees to minus 1. We know that's why, or n is equal to 0, 1, 2. We can write this. So capital N is equal to 2 pi by omega means pi into k. So 2k. So for k is equal to 1, n is equal to 2. This is the time period. So in this case, here if we write x n plus period is n, so we write xn here. So if we put x0, then cos 0 equal to 1, x1 is equal to cos pi by 4 equal to 1 by root 2, x2 is equal to cos pi is equal to minus 1, x3 equal to cos 9 pi by 4 equal to what we don't know. X is equal to 4 cos 4 pi equal to 1. So x0 is equal to x4. Okay, so n is equal to 4 because it is 0 plus 4, right? 0 plus 4. So this is n So we get this value, first value is repeated after 4 sample. So the period can be obtained like this also. So this is a lengthy process. We have to calculate large number of coefficients.